Continuing our look at optimization problems, and we'll look at a couple more examples here, at least set a couple more of them up. Let's take a look at number 16 and see if we can get a setup for that. We want to find the dimensions of the rectangle of largest area that has its base on the x-axis and its other two vertices above the x-axis and lying on the parabola y equals 8 minus x squared. So let's just get a picture of this thing. So here's our x, y. Now the parabola y equals 8 minus x squared. What does that look like? Well, let's see, if x is 0, y is equal to 8. So at 1, 2, 3, 4, 5, 6, 7, 8, it intercepts the y-axis in a parabola that opens down. And of course, it's going to intercept here at plus or minus the square root of 8 if you set that equal to 0. And 8 minus x squared equals 0. X squared is 8. X is plus or minus the square root of 8. 2 square root of 2. Now we want a rectangle, the largest area, base on the x-axis, and the other two vertices above the x-axis and lying on the parabola y equals 8 minus x squared. So we're going to want something like this. We're going to want a rectangle that has a base on the x-axis and then looks like this. So the area of this is what we want to maximize. Maximize this area. Now, area is always equal to x times y, or, well, I should say it's equal to base times height. I think what I'm going to do in this problem, in order to be consistent, I'm just going to maximize just 1/2 of the rectangle. If that's as big as possible, since it's going to be symmetric, then the whole area is going to be possible. So let's go ahead and maximize, let's maximize half the area, which is going to be x times y if I call this x right here and this y right here. Now again, the trick is to substitute in for one of the variables based on an equation and some other information, and this one's pretty much ready to go. We have y is equal to 8 minus x squared, so we'll put that in there. And now, actually let's put it down here, our area function for half the area is equal to x times 8 minus x squared. It's a function of x. We get 8x minus x cubed. And so we can solve that for x. Well, you can maximize that by taking a prime of x and setting it equal to 0. Solve that for x. So remember then, to find y, once you solve for x, you'll get looks like a plus or minus, two possible values for x. One will be the positive x, one will be the negative x. Your y value then you can get by just taking 8 minus that x value squared. So that's going to be the height of your rectangle. So you have to take your area, remember then, is going to be your max area. Your max area is going to be 2 times x times y. So 2 of those x's to get that total base there. So that's a pretty straightforward one. I probably should just let you guys figure that one out on your own. I tell you what, I'll let you figure out the Norman window one on your own. And we'll set up number 33 then. That'll be the last problem we have to look at, I think, in this section. Number 33, we want to find the equation, an equation of the line through the point 3,5 that cuts off the least area from the first quadrant. Alright, so maybe it doesn't make much sense when you first read through it, but that's why we draw a picture and try and make some sense of it. So we're going to draw here 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5, that's going to be this point here. So we want to cut off, what do we want to cut off? The least area from the first quadrant. Well, if I'm going to cut off area from the first quadrant, I guess that means I'm going to intersect both the x-axis and the y-axis on positive sides. So what we're going to have then is some line, let's try that again, some line that looks like that. And this area here is what we want to minimize, right? Because we want to minimize the area of that quadrant A. Alright, so let's see, how are we going to do that? What do we know about the area of something like this? Well, I guess the area of a triangle, remember, which is really what it's going to end up being, the area of a triangle is 1/2 base times height. So we're going to have to label our base here and our height here. Let's go ahead and label this x, since it's on the x-axis, and we'll label this height here y. So the area that we're trying to minimize is going to be 1/2 x times y, depending on what the x value is, where we intercept the x-axis, and the y value is where this line intercepts the y-axis. That'll be our x and our y value. Well, again, the problem is that we have two variables in our area function that we're trying to minimize. What to do? what to do. Well, let's see if we can get an equation for this line. This line, we have a line that goes through the point 3, 5. It also goes through a point x, 0 for some value x. That's this point here, and 0, y. And 0, y. So what's the equation of that line that goes to those points? Well, I've got a line basically with a y-intercept of y. And it goes to the point 3, 5. Well, all right, how about this way? Let's do it this way. We've got a slope of this line is going to be, let's see, it's going to be a negative y over x. So negative y over x is our slope. So our line is going to have a slope of negative y over x times x plus our y-intercept. Well, let's try it this way. Let's see here. Now this slope, negative y over x, is also equal to this slope point here, 3, 5. The slope from this point to this point, which is going to be y minus 0 over 0 minus x, negative y over x, has to equal the slope from this point to this point, which is 5 minus 0 over 3 minus x. And now I think we can solve for y in terms of x. Do you agree? We have that negative y equals 5x over 3 minus x. And so y is equal to negative 5x over 3 minus x. Let's see if this works here. Our area then as a function of x is equal to 1/2 times x times, let me do this, let me multiply by negative over a negative, so it's a positive 5x over x minus 3. So times 5x over x minus 3. Alright, so there's our area function. I think I'm doing this right. I may have to come back and amend this. I'm kind of just going on the seat of my pants here. A prime of x then is, actually let's simplify this a little bit. We've got 5/2 x squared over x minus 3. 5/2 x squared over x minus 3 is our area function. So, let's see, what can we say then about that? Well, we can say then that the derivative is going to be 5/2 times, let's see, the quotient rule here is bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1, all over the bottom squared, which is x minus 3. Alright, so let's see here. We need this to equal 0. So we need 5/2 times, if we take this as 2x squared minus 6x minus x squared, all over x minus 3 to equal 0. I think we're onto something here, maybe. 2x squared minus 6x. Yeah, I think that's going to be right. Now, divide both sides by 5/2 and multiply both sides by x minus 3. Basically, what you see is that we're going to need this numerator to come out to be 0. That's the only chance we have of this function coming out to be 0. So that's going to be x squared minus 6x equals 0, which means that x times x minus 6 is equal to 0. So we have two possibilities. One is that x equals 0. Well, that doesn't make any sense. That's not going to be much of a triangle. So that's no good. The other possibility, however, is that x is equal to 6. So that's probably going to be the one that we want. This point right here is going to be 6, 0. What is y going to have to be then? Well, y is 5x over x minus 3. So y is 5x over x minus 3, which is 5 times 6 over 6 minus 3. That's 30 over 3. That's 10. So we have the y value is at the point 0, 10. This picture is not very good, but we get the idea. Okay, and that means the area of the rectangle then, or the triangle, is 1/2 base of 6 times height of 10. That's 30, and that's just square units on that thing. And is that what we were trying to find? No, that's not exactly what we were trying to find, was it? We want the equation of the line. The equation of the line, well, y equals mx plus b. Our b value is 10, and our m was negative y over x. So we have y equals negative 10 over x, which was 6, times x plus 10. So y is negative 5/3 x plus 10. That's what we were looking for there, the equation of the line. All right, you should be in pretty good shape, I think, for this homework assignment, so do the best you can. Let me know if you have any questions. We're on the home stretch here. A couple more sections in 4, and then on to Chapter 5 for a couple sections out of there. So please, again, if you get stuck or have any troubles, get in touch with me. And by the way, the password for 4.6, that's not going to work, is indurate. Indurate or indurate, which means physically or morally hardened. INDURATE. Good luck on 4.6.